Welcome to Packard's capacitor training. Capacitors are used in many different electrical and electronic applications. In this course, we will focus on their use in HVACR applications, including compressor, evaporator, condenser, and pump motors. By the end of this course, you will have a basic understanding of how capacitors work with HVACR motors. You will be able to describe the types of capacitors. You will be able to answer customer questions and help them select the proper capacitor to meet their needs. You will also be able to identify common causes of capacitor failure. What does a capacitor do? A single-phase AC induction squirrel cage motor requires two phases to start. The capacitor will create an artificial second phase that allows the motor to start and run. A capacitor is a device capable of storing and releasing electrical energy. Capacitors used in motors are usually made by placing a flexible layer of insulating material, or dielectric, between two thin strips of highly conductive metallized foil, like a sandwich. The sandwich is then rolled up and placed inside a cylinder for protection. As a capacitor is energized in an electrical circuit, electrons build up on one of the foil strips. At the same time, electrons are pulled away from the other foil strip. Because the two strips, or plates, of metal foil are insulated by the dielectric, an excess of electrons, a negative charge continues building on one plate and a lack of electrons, a positive charge, on the other. The difference in electrons between the plates is referred to as the potential differential. The capacitor not only stores energy, but releases it as well, 120 times per second in a 60 Hz AC circuit. This release of stored potential energy causes a delay in the normal current flow. When the delayed current is applied to the start or auxiliary winding of an AC motor, the electromagnetic field of the winding is phase-shifted at an angle to the electromagnetic field of the primary winding. This causes the two fields to chase each other around the motor stator and attracts the rotor in the direction of the rotating fields. The motor now has starting torque as well as direction of rotation. Capacitors are rated in microfarads, or MFDs. A microfarad is 1/1,000,000th of a farad. A farad is the measure of charge required to produce voltage change. There are two types of capacitors, a start capacitor and a run capacitor. Let's take a look at each. A start capacitor works intermittently. It is only in the circuit while the motor is starting. It works with the start winding to quickly bring the motor up to its operating speed. In this type of capacitor, either a switch or a relay removes the start capacitor and the start winding from the circuit. The start capacitor has a high microfarad value relative to a run capacitor. This allows for a greater phase shift to provide more starting torque. A run capacitor works continuously. It is in the circuit at all times. A run capacitor works with the auxiliary or phase winding to increase torque and efficiency while lowering the amps of the motor. The run capacitor has a lower microfarad value, typically 5 to 15 MFD in most HVAC applications. In the case of a capacitor start capacitor run motor, the start capacitor is in the circuit only while the motor starts. The run capacitor is in the circuit at all times. Capacitors are rated by microfarad, manufacturing tolerance, voltage, and ambient temperature. The tolerance on a run capacitor is the manufacturing tolerance that occurs in this capacitor. Tolerance may vary from manufacturer to manufacturer. The notation UF is a substitute for MFD in electronics literature and is often displayed on capacitor labels. The capacitor label shown on the left is from a 4 microfarad capacitor manufactured with a plus or minus 6% tolerance. Start capacitors normally do not show a tolerance, but do indicate a microfarad operating range on the label, as on the capacitor shown on the right. Manufacturers may have different agency approvals for their capacitors or the plants that manufacture them. This can reflect quality standards that have been achieved. These include agency or industry standards of UL, CSA, CUL, EIA 456, VDE, and ROHS. ISO is a manufacturing process standard that is also significant among manufacturers. The capacitor requirements are shown on the motor nameplate. The capacitor selected should match the microfarad rating capacitor requirements listed on the motor nameplate. Using a capacitor with a higher voltage rating than indicated on the motor nameplate is sometimes acceptable. Using a capacitor with either a higher or lower MFD than the nameplate indicates will result in negative consequences. Using a capacitor with a lower MFD rating than on the motor nameplate will lead to the issues listed. Using a capacitor with a higher MFD rating than on the motor nameplate will lead to the issues listed. If a capacitor with the required MFD rating is not available, you can create the proper rating by connecting capacitors in series or parallel. Let's take a look at how to connect the capacitors for either series or parallel. Perhaps a 10 MFD 370-volt capacitor is required, but you only have two 5 MFD 370-volt capacitors available. By combining the two 5 MFD 370-volt capacitors in parallel, you will attain the performance of a 10 MFD 370-volt capacitor. Perhaps a 10 MFD 440-volt capacitor is required, but you only have two 20 MFD 370-volt capacitors available. By connecting these two capacitors in series, you will attain the equivalent to a 10 MFD 740-volt capacitor. The MFD rating matches the requirement exactly. The resultant higher voltage rating is acceptable. While more space is required when you use multiple capacitors instead of a single capacitor, combining them is a workable solution in a pinch. And in some cases, it can even be a desirable alternative to using a single capacitor with the required MFD rating. For example, if you are experiencing premature capacitor failure because the capacitor is seeing excessive heat from the motor or the environment, using capacitors in parallel or series may help reduce the problem. Multiple capacitors mean more capacitor surface area is available, which can help dissipate the heat. This can result in longer capacitor life. How do you tell if you have a bad capacitor? You can use an ohm meter or a digital multimeter with the capacitance function. These meters have different advantages. Let's take a look at each. An ohm meter can indicate that a capacitor is taking a charge, but not if it is holding its rated charge. An advantage of an ohm meter is that it can tell you if a bad capacitor is shorted or if it is open, giving you some idea of what might have caused it to fail. If a capacitor is taking a charge, the needle will swing toward 0, then fall slowly toward infinity. If shorted, it will read near 0 and hold there. The capacitor is bad and should be replaced. A likely cause of a short is too much charge being applied in a short burst, enough to short out any resistors that may have been wired between the capacitor terminals. If open, the needle will not move off of infinity. The capacitor is bad and should be replaced. An open state is usually caused by physical damage to the capacitor. Look to see if it is cracked, smashed, burst, or leaking. A DMM with the capacitance function tells you if the capacitor is holding the charge at its rated capacity, something an ohm meter can't tell you. If the measured capacitance is within the capacitor's printed specification, the capacitor is good. If not, it is bad and should be replaced. When testing either a shorted or an open capacitor with a DMM, the result will be the same. For example, the MFD reading may rise slowly, then be replaced by OL, overload. Caution: before testing, disconnect the capacitor from the power source and safely discharge the capacitor. You must also disconnect any resistors between the capacitor terminals. The purpose of resistors is to limit the amount of current getting into the capacitor to prevent damage to it. You must disconnect resistors because they may be holding a charge and you want to be sure you are measuring only the capacitance of the capacitor itself. By replacing a bad capacitor with a new one, you can determine if the motor is operating properly. When you replace a motor, you should always use a new capacitor. The primary causes of capacitor failure are high temperatures and incorrect voltage. Sources of excess temperature can be ambient air, corroded or loose-fitting connections to the capacitor, or motor temperatures impacted by low or high voltage, improper fan blade or blower wheel, improper static pressure caused by blocked coils, dirty filters, kinked flex duct, improper position of fan blade or blower housing, and numerous other factors. To minimize the possibility of temperature issues reducing capacitor life, use a quality capacitor with the highest ambient rating available. For example, this 45 microfarad capacitor is rated to 85 degrees Celsius. That's 185 degrees Fahrenheit. We've created 3 charts to illustrate the typical impact temperature and voltage has on the life of a capacitor. There are several other related causes of capacitor failure. Contamination of the materials used in manufacturing will contribute to shortened capacitor life. Moisture and long periods of storage will also negatively impact product life. Using a quality-conscious and dependable supplier will minimize your concerns of defective products. When a capacitor fails, in addition to checking the capacitor, the technician needs to be certain that the motor is operating properly as well. For example, a sticking relay will keep the start capacitor in the circuit too long, creating excess heat in the capacitor and the motor windings. Be careful when working with capacitors. Always remember that they store an electrical charge. The use of a 2-watt, 20,000 ohm resistor to discharge the capacitor is recommended. Placing the blade of a screwdriver with an insulated handle across the capacitor leads will also discharge the capacitor, but it can damage the capacitor. Your knowledge will ensure your customers receive the best service in town. You will be able to help customers select the proper capacitor to meet their needs and help them identify the cause of capacitor failure. Thank you for taking this training on how capacitors work with HVACR motors.